Addition reactions are when an alkene reacts with some set of reagents, and these reagents have basically two parts. In some cases, one of the components, say group A, is going to be an electrophile, and one of the components, B, is going to be a nucleophile. When these two react, what you form is technically an addition of the two pieces, okay? So A becomes bonded to the alkene or the organic fraction, and B becomes bonded to what used to be the alkene, and now it's an organic fraction. So what you're doing is you're converting a pi bond and usually a sigma bond between groups A and B, and you're converting these to two sigma bonds. Now, usually the pi bond is weak. This is moderately strong, but these are going to be, generally speaking, stronger sigma bonds that you make, okay? So the reaction's exothermic or downhill in energy, and this reaction goes from left to right. In one case, it is actually uphill in energy, but we don't need to really worry about that too much. Okay, so let's look at the different reactions in overview. Okay, let's just use cyclohexene as our typical reactant here. Now, water is a reactant, and you have conditions for each of these reactions, generally speaking. And what you're doing here is that you're adding water to the alkene. Normally we don't draw H, but I just wanted to highlight that. Okay, so you're adding water to an alkene. This is called hydration. Okay, so this is a hydration reaction. You can also react alkenes with hydrogen halides. Okay, HBr, HI, HCl are the examples. And what you form here is an organohalide. I was going to put chlorine. It could be chlorine, bromine, or iodine. And so this reaction is called hydrohalogenation. Okay, so keep in mind that X can be any one of these halogens. We usually don't talk about fluorine in the context of sophomore organic chemistry. Now, let's talk about hydrogenation. You probably have seen partially hydrogenated vegetable oil on the back of a potato chip bag or something. Now, what you're doing here is you're basically erasing the pi bond. We normally don't draw hydrogens, but I need to add them here because I'm talking about it. And this is called hydrogenation. Hydrogenation, okay? And you need catalysts, and there's certain conditions involved, but this gets us started in thinking about all of the names of the reactions. Let's look at some more reactions, okay? If we have an alkene, this can react with a halogen, okay? And so again, X is your chlorine, bromine, or iodine. And what you form from this is a halogenated product, okay? So you form a dihalide, okay? So those could be two chlorines or two bromines. Normally we do this with chlorine or bromine only, so I'll erase that. And so this reaction is called halogenation. Okay. And so we'll learn that with chlorine and bromine. And let's look at another reaction here. Again, we're just using cyclohexene as the common starting material. And here there's different things, but I'll just write X comma OH. Don't worry too much about this, but X can be chlorine, bromine, or iodine. And what you form from this chemical reaction is a halohydrin functional group. So this is called a halohydrin. Okay. Is it called a halide? Is it called an alcohol? It's called a halohydrin. So that's what this is called. And the name of this reaction, surprisingly enough, is halohydrin formation. Okay, so you need to know what a halohydrin is before you can learn about its formation. And then we have dihydroxylation. Okay, and these are the ones that are illustrated in the Klein second edition chemistry textbook. So those will be the ones I'm talking about. And so we have two hydroxides. One is here and one is here. So we call this a dihydroxylation. Okay, there's many other reactions, and some of those are covered in other textbooks. This is called a hydroxyl group. Okay, and it's a part of the alcohol functional group, so that's why you have this hydroxyl in the name here. Okay, so we're going to introduce all of these chemical reactions. This summarizes section 9.1 in the Klein's organic chemistry textbook.